We're asked to sketch this function over this interval. So that means from x equals -2 to x equals +2. Oops, supposed to delete that, but it's not doing it. From x equals -2 to x equals +2, we're supposed to graph the function. So why don't we make a couple, why don't we plot a couple values, make an x and y table. You can do this with any function in math if you're just trying to get an idea of what it looks like. I can show you why it's going to make a certain shape too. There's an algebraic reason why. Okay, so let's try plugging in the left endpoint of the interval. Let's plug in x equals -2. If you plug in -2 and you square it, that makes +4. 4 minus 4 makes 0, and the square root of 0 is 0. Let's plug in the right endpoint. Let's plug in x equals 2. 4 minus 2 squared, that is going to do the same thing. It's going to give us 0. Then let's also try maybe if we plug in x equals 0, because that's halfway between those two. If you plug that in and simplify, you're going to get y equals 2. And if you keep getting some decimal values, sorry, I'm on a laptop right now. There we go. But on a laptop, I can't draw it. It's an x and y graph. Here's -2, here's +2, -2 in the x, +2 in the y. Put those dots. Those are data points that will be a part of the function. And then we got y equals 2 up here, just a rough sketch. And then if you keep putting dots, you're going to see it's going to make a nice curve through all those. It's a semicircle, okay? So the sketch of the graph is a semicircle. And then the question does something else. It asks you to find the area between the x-axis and the graph using rectangles. And they want you to approximate above and below line. So here's what they mean by above the lines. They mean, and actually there's extra details there I forgot to mention. The squares are confusingly 0.8 by 0.8 units. They're not a full unit. If you look at the x-axis, here's where x equals -1. So this is -0.2, -0.4, -0.6, -0.8. So these are the squares that they're referring to, these squares in the graph. Okay? I don't know why we're doing it like this, but we can answer it the way WebDesign wants us to. So if we're trying to estimate the area using those squares of 0.8 in side length, here's a square, here's a square. There's another square that kind of goes off screen. The red squares I'm drawing right now are the over approximation squares, because if I'm going to only use 0.8 squares, I'm going to have to take a big over approximation square over here, right, to capture the area. So this is the over approximation part of the question. And I'm just going to do 1/2 because it's a semicircle, so I can just double it for the other half. So there, 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 times 2 makes, there's 16 squares for the over approximation. So you want to calculate the area of one square, and then you'll want to multiply that by 16 to calculate the above estimate. And now for the below estimate, they want you to only take the squares that don't go above curve that you've graphed. So this square is fine, that doesn't go above. This square is fine. And this square is not fine here because if you were to take this square, you're over approximating a bit. We're only supposed to be under approximating. So if we under approximate, it's just these 3 squares on the left side. So 3 times 2, there's 6 squares for under approximation. So the under approximation would be the area of just one of these 0.8 by 0.8 squares times 6. And then the last part here, I think it asks for the exact answer. I think I cut that off. Look, it's a semicircle, right? So find the area of the circle and then divide that by 2. That's the area of the semicircle.